belong to Indian Railways. I worked for almost 34 years now, more than 34 years. And I have worked with the Delhi Metro, L&T Metro Hyderabad, and I can say that the first CBTC project that became operational in the country, that was in Kochi, I was involved there. Then Delhi Metro, of course, I had a long stint and was working on conventional train control system, then CBTC, and then UTO also. That's briefly about me. So coming back to the present topic, India's first ETCS level 2 signaling system, which is being implemented on one of the corridor here in National Capital Region. So if you see here, Indian government decided that we will decongest New Delhi, National Capital Region, and hence selected these 8 corridors where the technology what we have selected will be implemented for signaling system. So if you see here, the red ones are phase 1 corridors. For foreigners, it may be difficult to comprehend, but for others, first corridor is Delhi Metro, Delhi Meerut, the second one Delhi Alwar, and the third one Delhi Panipat. And then the next 5 corridors are for phase 2. So the first corridor, which is Delhi Meerut, the total length is around 82 kilometers. And since we have chosen that the design speed would be 180 kmph, so hence the travel time would be less than an hour from Delhi to Meerut. So these are the 3 corridors. First one, Delhi Meerut. And why I have chosen this slide is to show you that initial plan was that these 3 corridors will be separate, but then later on we decided that let us merge them at one point, and that is at Sarai Kale Khan. And if you see here, the Delhi Meerut corridor ending here at Sarai Kale Khan, then Delhi Alwar and Delhi Panipat, and the convergence point is Sarai Kale Khan. And automatically, if the 3 corridors have to converge at one point, then the signaling system has to be either same or interoperable. So choices would be obvious, so we'll touch upon that in later slides. And just because it's converging at one point, so seamless movement to the passengers would be available. One important aspect which we have taken care of is efficient multimodal integration. In fact, that's our main focal point, the focal point of my ministry also, that extensive multimodal integration has to be done. Apart from that, the usual things, safety, enhanced comfort, reduced capital costs, O&M costs, and other things. So this is a larger map of the first corridor, and there are around 25 stations, 2 depots, and one of the important thing here is the far end of this, you will find that these stations are quite close to each other, around 1 kilometer or so, and the reason is there was another metro corridor that was planned initially in that region, but then that was subsumed into this corridor, and hence you will find that initially these interstation distances are of the order of 5 to 10 kilometers, and later on it's only 1 kilometer. And the layout has been chosen such that the long distance train will skip those metro stations. And so the layout arrangement allows metro trains to stop at every station in that area, whereas RRTS train, Regional Rapid Transit System, RRTS trains will skip those stations. And that's how this integration was possible. We could subsume that metro and save huge costs. So for technology selection, this was another important aspect that need to be taken care of. So just a few features. The maximum, or rather I would say design speed is 180 kmph. The operational speed is 160 kmph. And automatically, if it is 160 kmph and the way stations are placed 5 to 10 kilometers, so average speed would be slightly more than 100 kmph. Trains will run at every 5 to 10 minutes. Of course, the design headway is much lower. And since it is Goa 2, Goa 1, Goa 2, so it's a weatherproof service. A few more features. Throughout 2 tracks, elevated, underground, nothing at grade. Depots are, of course, at grade. Standard gauge, 3.2 meter wide coaches, 25 kV. And one important thing is that out of the 6 coaches, those are there, 1 coach is the business, or we call it premium class coach. So there is a distinction. Out of 6, 5 are for general public and 1 for premium class. Out of 5, we have 1 ladies coach also. Now, so considering all these things, we had to decide about the technology. And knowing fully well that the first stage of the first corridor has to be commissioned by March 23, and we intend to prepone it to December 22 this year, matching with the 75th year of Indian independence. So we had to see that, okay, few things have to be we have to do it in a conventional way so that there is no hiccup, and then we can have some forward-looking approach. So I'll touch upon those things. So the conventional, as you know, interoperable, high speed. So the choice was very obvious that it has to be ETCS level 2. We had a lot of experience with CBTC, but we know that CBTC cannot operate at higher speeds, 160 kmph. So obvious choice was ETCS level 2. Then it has to be interoperable because it is converging at one point. So again, CBTC cannot be adopted. So it has to be something which is globally available in Europe, particularly, that is ETCS level 2. And then we also wanted ATO. ATO is not implemented at many places over ETCS level 2. But then we had a choice that, okay, initially you can begin with manual operation and perhaps later on you can switch on to Goa 2. So we decided that, okay, since there are already few implementations on in a standard way, not truly standard, but in a standard way, ATO over ETCS, so we decided about that. And then we also wanted smaller headways because we want, if I look at the 2040 or 2050 horizon, then probably headways of the order of 5 minutes would be needed. So we require a technology which can cater to this requirement, and hence we decided about ETCS level 2. and going for the latest baseline and release. Now, this was one aspect which is a little complicated, but we had no choice, because for ETCS level 2, you need a communication backbone. We had decided that we'll go for LTE. For LTE, you need spectrum, and spectrum is not something which is available over on the platter. You have to get it, and we are still trying to get the final spectrum. But then, since that was not available, we decided that okay, we'll go for ETCS level 2 for the first in the beginning phase. And whenever we get the spectrum, we can change over to level 2. Fortunately for us, the government has decided that, okay, for the first stage, they have given us some temporary spectrum in 900 megahertz band, 1.4 megahertz. So we'll manage with that, and we'll straight away go to ETCS level 2 over LTE communication backbone, which initially we had decided that perhaps we'll have to go only on level 1. But of course, we have crossed that hurdle. So, but still, the design or the requirement is that, okay, whenever level 2 is not available, we'll fall back to level 1. Now, this is one important aspect, that looking at the global scenario and how ETCS level 2 was progressing, we decided that, okay, we'll go for hybrid level 3, so that we can get the closure headways, and that's only possible if we have something like this. So we decided about this. Of course, hybrid level 3 may not be available in the December 22 commissioning, but yes, we have given some time to the vendor, and they are in advanced stages, and we'll be having hybrid level 3. I have deliberately removed those technical slides of hybrid level 3. Maybe many of you may be knowing that hybrid level 3 means that you have virtual physical blocks which are used by the system instead of the block working from station to station. So this was one important thing, and since we have subsumed MRTS also into our corridors, and the expectation is that headway has to be very low in that particular area. So hybrid level 3 would be quite useful from that angle. For hybrid level 3, yes, one bullet which I missed, that the important requirement is that train integrity has to be there, and fortunately, ours is a metro-like environment where fixed consists are there. So train integrity is available. Only thing is that that train integrity has to be designed or used by the onboard system, which currently is not there. But then when we were interacting with the industry, they agreed that, okay, they will be in a position to use this train integrity for the purpose of hybrid level 3. There are since the time allotted is very less, I had put this slide just to compare, provide the difference between ETCS level, hybrid level 3 and CBTC. I'll just say that the only difference is true moving block, which is available in CBTC, and virtual moving block, which is available in hybrid level 3. That's all, and I'll skip this slide. So most of the things are same, except the true moving block and virtual moving block. Right. So then ATO. Nowadays, you know that no system which is something similar to the metro works without ATO. And we found that since there are some subsets available for ATO by Unisig, so we decided that okay, we'll go with ATO over ETCS level 2. And vendors also accepted that. There were few implementations in the global scenario, like in Mexico or in London, in UK also there is one implementation on ATO over ETCS. So considering that scenario, we decided that okay, we'll go for ATO over ETCS. Now this is something which will be done for the first time in the world, and that is PSD over ETCS level 2. What we had decided was that since we will be having some skipping trains, and therefore the run-through speed on the platform would be of the order of 100 kmph. And if the trains have to skip at that speed, then you need a protection for the commuters who are standing on the platform. And therefore, we decided that, okay, we will provide platform screen door. The spare packets, those are available in standard implementation of ETCS level 2. That packet 44 we will be using for PSD interface from onboard to the track side. Communication backbone, as I've already said, that since GSMR was phasing out, we decided that we'll go for LTE. The final spectrum is yet to be allotted, but yes, with temporary spectrum on the first stage, we'll be implementing this over LTE. Today's scenario is that we have already commissioned it. We have not made it operational so far. Only some indoor trials are going on, but we are ready with the temporary spectrum which is allotted to us. This slide just I have added only to show you that to begin with, we are not providing LTE on high mass. We are providing LTE antennas on the viaduct itself over on some smaller mass, 6-meter height, so that the coverage remains limited. Of course, this was with the idea that we were initially thinking that we will be sharing the spectrum with the Indian Railways, but later on it was decided that okay, we'll have a separate spectrum. Then probably on a later date we can revise the design, but today the scenario is that we are putting LTE antenna on the viaduct itself on smaller heights. And this is what we have seen, that in other countries, especially China and Korea, they have been very successful in implementing ETCS level 2 over LTE. Then yes, we also want to set up something similar to SEDEX and Multitel in Europe. It may not be exact replica of that, but yes, we have covered this aspect in our requirement in the contract, and we expect to set up the interoperable lab because in any case, when we are going to the next corridor, there could be some other vendor, and then we will need interoperability to be tested. So we'll have our own lab. Of course, as a backup, SEDEX and Multiple and many other labs are there in Europe who can do this job for us. Apart from that, other lab setups will be there for PSD, for telecom items, for LTE. Then just briefly touching upon the other infrastructural things, we'll be having OCC and backup control center. Another important thing is that we are equipping ETCS on the maintenance vehicle, which has never been done in the country so far. So we'll be providing onboard equipment, and we'll ensure that these maintenance vehicles also run at equally good speed on the corridor, so that these long distances, 82 kilometer, in other section 100 kilometer, so the maintenance vehicle can reach to the maintenance site at a very small interval or in less time. And the third bullet, if you see here, this is another thing. We are providing distributed acoustic system on the first corridor, end to end. As a, I mean, people can say that whether track failure or track break can be detected really or not, but yes, we are providing, because it will help us in knowing the health of track as well as wheel, and maybe other things like people walking on the track. So this also we are providing on the first corridor. Complete operation and maintenance of this first corridor is being privatized. We have awarded this contract, and in fact, we are signing it today. The first operation and maintenance contract to the private party. And of course, we are also implementing asset management system, comprehensive asset management system, where in all point or linear assets will be covered, and we want to really exploit the technologies available in the market for operation maintenance. And therefore, this particular asset management system, we hope that we'll be able to really utilize this to create that environment, so that the latest technological inputs can be used in operation and maintenance. In fact, we have a lot of ideas to use this. So just the conclusion, we have already covered that, and one slide which I had skipped actually, so it's not there, to show that how we will be skipping these stations, but that's pretty normal, that faster trains running and then providing loop lines for the shorter and slower trains. And that's all from my side. Just I rushed through in last 15 minutes. Thank you very much.
Thank you, Mr. Kaushik. You mentioned a very brief overview of the project, along with many firsts in this project, which will, I feel, definitely go a long way in further infrastructure projects being carried out on various railway systems in India. Before proceeding further, I will like to mention that there is slight variation in number of papers as mentioned earlier. I mentioned 6, it's 7. One more paper, that is IRC, a global professional body of S&T professionals, will be covered by Mr. Nikhil Goswami and Mr. Pradeep Roy. I apologize for that. So the next paper will be taken up by Mr. Pradeep Roy on digital railway challenges. I invite Mr. Pradeep Roy to present his paper.
Good morning to you all, and thank you, Mr. Meena, for allowing me to come and present this on the stage. And thanks to IRC and IRST, both in India and UK, that to give me an opportunity to speak about the digital railway challenges. Just to give a brief introduction about myself, is I have worked in the railway industry for the last 33 years, and I had an opportunity to work in multiple fields. Like I worked in medical instrumentation in my previous career, railways, and I had a chance to work in the defense, also in the field of safety. And I've also worked in another project in Amsterdam, or a magnetic bus, which is driving on the road, which is with the driverless. So this one that I want to mention about the hurdles that we have faced. Actually, I just want to borrow one of the things from Mr. Swami that he mentioned yesterday about the duck that is moving on the water. I'm trying to move like the swan. So I want to speak about the hurdles that the swan is having inside, and this is to completely my own concept of what I had faced during the commissioning of the first UK level 2 signaling with a line site, and because it was a completely new project for UK, which I started sometimes in the end of 2012, and we have come across some of the things that we need to cover. One of the most important things that I like to say here is we do speak about digital challenges, and we are not very, I can say till now, we are not very confident and fully accustomed to the process that we have already covered so far. There are still a lot of challenges to go, and there are still a lot of inputs that we need to cover these areas. So let's start from the very beginning. So what's the journey? So I'm moving with the journey that we have started with orthogonal signaling, which we have mostly prepared. Then we have started with the conventional signaling, which is the rod-operated signaling. Then we have started with the conventional panel-operated signaling with line-side signaling. That we are coming into the route relay interlocking, the computer-based interlocking, and now we are into the digital world. So we had a long journey of the signaling that we have come across. So we are coming into the new area. So we are stressing on what is a digital signaling that we really mean. So what actually we had the conventional signaling with the fixed block, with the automatic blocks, all those. Then going into the digital signaling, we have ETCS level 1, we have ETCS level 2. We have spoken about ETCS level hybrid, what Mr. Kaushik has mentioned. Then we are going to ETCS level 3 in the future, and of course we are moving towards ETCS level 4. Of course, it's still a long distance, but still we might be reaching sometime, someday. But my important note is, we cannot do today's job with yesterday's technology and be in the forefront tomorrow. So what is digital rail? So we have spoken about many things about digital rail. We have actually covered it. It enhances the infrastructure. It gives the safety. Most important factor that it comes about, it is about the information that we need for the passengers, because passengers need information on their fingertips. They need to know that when my train is moving, am I going safely? So one of the important things that we are coming into the digital signaling is we are not depending on the drivers to run the train. We need them, but we're not depending on the safety of the drivers, the safety of the passengers, for the driver to, whether they spad a signal or they run very fast or they run very slow. Of course, timing is very important for them to reach the destination at a particular period, because we want to shift the people from road to rail for better comfort, better safety, and better timing. So that's all the concept, but we are coming into the digital rail. So what the digital rail systems covers, it's an ETCS system. It's a traffic management, the connected driver advisory system, and the telecom. So we have got so many things that need to cover, unlike a conventional signaling system. And of course, this is not a simple one. This is very complex. So in order to achieve this, we have come across a number of challenges. So my introduction to this one will be, what are the challenges that we are actually facing in this system? So if we look at the challenges, we have the digital technology, which actually is filled with all the things like we have mentioned previously, the traffic management, the CDAS, the ETCS, the GSMRD, and the cloud. So what we come across, we have come across the different aspects of the challenges that we have faced in different parts of the situation. So we have, it is of course is complex environment, it's a technology, it's a system of systems, you have a lot of changes in the application design, a lot of changes in the training, maintenance, operations, and whatnot. So important thing which has been come out in a few papers earlier, that it requires an 80 individual sequences to be carried out properly before and for a single train to run in to give a movement authority in a safety mode. So I'm going to work out on these challenges and highlight some of the issues on the major ones that we have come across. The first one is in the case of the challenges is the requirement. What do you require? Because in the conventional signaling system, we have actually covered what are we requiring in terms of, because we have a system that is, which you mentioned as the COTS. We have a system that is well known, people are well versed, and of course it is a well approved system. But here it is not. We have actually covered it covers the identifications, it covers the requirements. So requirements are not coming that in terms of like we have got an Excel sheets, we populate it. The requirements comes in terms of what we call as the DORS model. So DORS model actually covers the requirements, but each requirement is not fulfilled by a particular justification. It requires multiple steps to cover for a single clause, and you have to cover all this in different stages, and especially in the systems, it's much more better. So the first requirement is what the client looks at it. The client looks at, they define the requirements, they say that I need this one. Oh, sorry, I hope I haven't finished it. Okay, the client's requirement says that it is the, they says that I need this one, I don't want to run my trains. That what Thameslink has done was to run the trains at 24 trains per hour. So we had a congestion area where we had line side signaling, but it was inoperative to run 24 trains an hour with that block. So we had to have virtual signalings like the block markers, which we have, that's a cover from the project point of view. The second that covers, we have a lot of systems requirement. Systems is because we have individual systems which I'll be coming later. I'm not disclosing it at this moment. So systems requirements covers a lot of inputs. So the system requirement is actually covered by subsystem track side. So we have the balises, we have the LEUs, we have the different type of track circuits that feed in the information, that collect the information, pass it on to the train, and provide this information back into the interlocking. We have the telecom requirements, which is the communication that is taking place between the train and the RBC, which feeds in informations from the interlocking and back into the train. Finally, we have got the operational requirement. What are the things I need to cover in terms of maintaining how the system will be used, that is from the signaler's point of view, how the systems will be maintained, that's from the maintainer point of view, how the systems will